এতিয়া এক্সেক্টলি টাইম হ'ব আপুনি মোক কৈ দিব নে এতিয়া okay. Okay. Thank you everyone for joining me in the live session today. My name is Debarshi Das. I'm a faculty at the Humanities and Social Sciences Department at the Indian Institute of Technology, Guwahati. So this course is Mathematics for Economics Part 1. And this is, I think, the second live session. We had, second or third, I've forgotten. So this is the last live session of this course. And in the last couple of weeks, actually after the last live session, we have covered around 4 weeks of things, 4 weeks of material, and the assignments also have been given to the students, and the students have been instructed to submit the assignments within the specified date. So I hope that all the students who have registered in this course have submitted their assignments and they have got their marks also accordingly. So this live session is going to be about that part of the course which you have covered since the last live session. I think in the last live session we covered till the eighth week of this course. So this live session is going to be about the last 4 weeks of the course. So 4 weeks means what? In the last 4 weeks we have covered mainly two big topics. One is the topic of integration, I think. The idea of integration and its application in economics. That is what we have covered. And that is one. The other one was about the difference equations. So I have also already given the assignments for these two topics. So maybe the students who have registered in this course have already submitted the assignments. Nonetheless, if you have any questions or queries regarding the assignments or about this part of this course, the material that we have covered in these 4 weeks, then you can ask me questions regarding those materials. So this is being webcasted in the YouTube channel also, the YouTube channel of IITG IIT Guwahati. So people can view me on YouTube channel and they can type their questions on the YouTube channel as well, or they can join directly in this live session in this platform, NPTEL platform. So I'm still waiting for any questions or comments from the students of this course. Meanwhile, since this is the fag end of the course, So the exams are the tests are due. So today is 21st. Um, so I think the exam is scheduled on the 1st of November. I think. Let me check. Yes, the exam date is 1st of November. So as it has been it has been announced to the students that there will be two sets of exams of this course. So any out of these two sets of exams, um, any one exam will have total marks of 100. So the students have to attempt those questions of 100 marks in any of the exams. Uh, so that is basically the format. And the syllabus is the entire syllabus. I mean, from week 1 to week 12, whatever we have covered, that will be the syllabus for the exam. So in this last 4 weeks, what we have covered, I think in week 9, the topics that we covered were integration, area under curves, indefinite and definite integrals, integration by substitution, and discontinuous functions. So applications of these different ideas of integration regarding integration were discussed, and the different ways to integrate functions. Those are the subject matters of this week 9 and week 10. And we talked about the fact that we can use the tools of integration to analyze, for example, inequality, right? Uh, we have talked about, the idea of Lorentz curve through which inequality can be measured. Also, we talked about the application of integration to find out the present value where you have continuous discounting. Uh, and there are so many other several, applications of integration, especially when time is involved. Then integration is becomes a important tool when you are, dealing with time in economics. Um, and Then we talked about difference functions, difference equations, and difference equations. What do they mean, right? Uh, Essentially, difference equations are like differential equations, but there is a critical distinction that in difference equation, time is taken to be discrete rather than continuous. And then we look at how we can analyze a variable which is moving across time, right? Um, how can we describe the trajectory of a variable which is changing over time, but the time could be discrete, right? In this case, in the case of difference equation, the time is discrete. So, so difference equation is related to that. Um, so we talked about several applications of difference equations, but essentially we just like differential equations are solved. Um, so you get a variable which is changing with respect to time as a function of time and some other constants. Here in case of difference equation also, um, similar kind of solutions are obtained, and there could be different in solving difference equations. We talked about two kinds of solutions of difference equations. One is first order and the second is second order difference equations. Um, and we have seen how to solve first order and second order difference equations. We also noted that initial conditions are important to get a solution. We can all, of course, find a general solution, but to get a particular solution, mm, the initial conditions are important, just like it is in the case of differential equations. So although there are various parallels between differential and difference equations, at the same time, we found that the idea of stability, right, or whether the trajectory of the variable which is changing with respect to time is going to converge or is it going to diverge? Is it going to oscillate indefinitely or maybe oscillate but not indefinitely, but a sort of damped oscillation? Those details are a little bit different in case of difference equations than in case of differential equations, right? So when you talked about the idea of stability, conditions of stability, those conditions of stability in the case of difference equations, those conditions were quite distinct if we compare them with the stability conditions of differential equations. And why talk about difference equations at all? Uh, because in real life, when we analyze variables, then in economics especially, the variables are generally denoted with respect to time, but that time is often discrete. For example, you can think about one financial year and another financial year, right? So years, financial years are like chunks of time. So these are not continuous variables. Even if you subdivide a year into smaller portions like a quarter, which economists do, quarter means 3 months in a year. So there are 4 quarters in a financial year. Then also the quarter is nonetheless a chunk of time. It's a discrete variable, not a continuous variable. So the main point that I'm trying to make is that in economics, although time is experienced as a continuous thing, but when you record time in economics, it is done as discrete units. It could be a year, it could be 3 months, it could be a day, it could be a week, a month. All these are discrete units. So one has to have a tool of analysis um, of analyzing variables when the time with respect to which the variables are changing are not continuous but discrete. Therefore, I think especially in economic analysis, there is a large scope of difference equations rather than differential equations, right? That does not mean, of course, that in economics differential equations are not used. Differential equations are also used. Depends on the context in which we are talking about. So, depending on the context, differential equations can also be used in economics. And so, in this course, I did not cover differential equations and its applications, but it is there. As I mentioned, I think in the last interactive session, that this course is only part of a larger undergraduate course. This is Mathematics for Economics Part 1. So if I had to propose a syllabus for the entire course of Mathematics for Economics, then I would have included differential equations as well. Okay, so I do not find anyone asking anything or making any comments, anything, any comments on this platform. Neither is there any comment on the YouTube channel. So I think maybe this is because of the Diwali effect. Uh, we just had Diwali yesterday and the day before also. So maybe this is a sort of momentum of the Diwali, which is keeping people away from this session. So shall we close this? Shall we call it a day if nobody is joining online? Okay, then we stop it, no? Okay, thank you. Yes, thank you, whoever has been here for your time and all the best for the exam. Thank you.